Bismillahirrahmanirrahim. Hi everyone. I am going to revise with you question by question this revision guide to help you inshallah to score very high in the coming end of term exam. Hi everyone. In this video we will describe learning objective 2. Learning objective 2 is to understand that all substances have characteristic properties. Characteristic properties means the properties which is characteristic for substance. There are two characteristics that we need to differentiate between them. First one we call it extensive property, and the second one is intensive property. What is the difference? Extensive property describes the amount of matter in a sample. So it depends on how much matter you have. So if you increase the amount you have, the value will change or will increase. Volume, mass, length, and width. All of them are described as extensive property. While values like color, hardness, density, melting point, boiling point, absorbency, malleability, ductility, electric conductivity, those properties are described as intensive. Intensive property, they are the properties that depend on the type but not on the amount. So if you change amount, you are not going to change melting point or boiling point or density or color of any substance. Now let's start answering questions. Question 1. Explain why all samples of a given substance have the same intensive properties. So if you have substance A, for example, and you have another sample, if substance A has two samples, you got them from two different sources. Like for example, if you have water and you got water from two different places, do the intensive properties change? No, they won't change, because every sample of a given substance have the same chemical composition. Water is H2O everywhere. It doesn't depend on the resource, it doesn't depend on the amount, it does depend only on the type, and the type depends on the chemical composition. So if the chemical composition doesn't change, mean that the intensive properties will stay the same. Next question. Name two categories used to classify properties of matter. Properties are either intensive or extensive. Next question. Explain why samples of platinum and copper can have the same extensive properties but not the same intensive. It's very logic. Platinum and copper are two different metals. They have even two different symbols in the periodic table. They have different masses. They have different composition. So if they do have different chemical composition, they never have the same intensive properties. But they might have the same intensive property. I can get equal masses of them. I can get equal length. You can get equal volume. Right? So they might have the same extensive properties. But for the intensive properties that depend on the chemical composition, and because they do have different chemical composition, they have different intensive properties. Describe the difference between extensive and intensive property and give an example for each. Very simple, you are going to recall the definition. Extensive property, it depends on the amount of matter, while the intensive one depend on the type of matter. Mass and volume are extensive properties, while color and hardness are intensive properties. You can give another example if you like. Next question. How could you distinguish an element from a compound? Compound can be separated by chemical means, while the element cannot. Next question. Classify the following materials as an element or a compound or mixture and give reason. Table salt, as we have just said in the previous video, it's a compound. If you have given a formula or a complex name, so it should be a compound. Salt water. Salt water should be a mixture because it's made of two compounds, salt and water. Sodium is an element because it's made only of element atoms. You know the element if it's in that periodic table. Next question. Is malleability an extensive or intensive property? In this kind of question, just to mention, is it intensive or extensive, and give the definition of the property. So malleability, ability of substance to be shaped. So it depends on the nature but not on the mass. So this is an intensive property. It depends on the type or nature but not on the mass of the sample. Classify each of the following as extensive or intensive. Conductivity. Conductivity doesn't depend on the mass, depend on the type. So I can say copper conducts electricity, but wood doesn't. So it depends on the type of metal. Doesn't depend on how much wood you have or how much copper you have. So it's an intensive property. Density is an intensive property. Volume is an extensive property because I can have a beaker or a measuring cylinder which has a big volume of water, and you can change and take a small volume of water. So the volume, the value, here I can read 10 centimeter cube and here I can read 50 centimeter cube. So the difference in volume depends on the amount of substance you put. Now let's move to learning objective 3. Learning objective 3 is describing the physical and chemical changes and chemical and physical properties. Question 1. Describe two categories used to classify physical changes. Physical change of matter can be either irreversible or reversible. Irreversible cannot be undone. Reversible can be undone. Like what? Like if you have a piece of paper, cutting a piece of paper. Is it chemical or physical change? Yes, it's a physical change. But is it reversible or irreversible? It's irreversible because you can't get them back. Like breaking glass. Breaking glass is also a physical change, but it's also irreversible because it cannot be undone. While melting ice, it's a physical change because you change the matter from solid to liquid. It's a physical change, and reversible because it can be undone. You can refreeze the water back. Look at this question. Explain, is freezing of mercury a reversible or irreversible physical change? Freezing is reversible. Change state is reversible. Whenever you have question on change state, it should be only reversible change. Next question. Explain is a name two physical properties that could be used to distinguish between water and ethanol. If you are asked about physical properties, you should mention only intensive properties because they are two different substances. water and ethanol. So it's a melting point and boiling point. You can write density, you can write color, but color is not working here because water and ethanol have the same color. Both of them are colorless. So choose any other intensive property. Next, name one physical property that could not be used to distinguish chlorine and oxygen. You should mention any other properties that both of them have this the same property. Chlorine and oxygen, like state, both of them are gases. Okay, we cannot say color because oxygen is colorless while chlorine has a green color. I can't say color. So the answer here is state. Then explain why sharpening a pencil is a different type of physical change from freezing water to make ice cubes. Sharpening a pencil and the other property and the other action was freezing water. Freezing water is change in state from liquid to solid. Both of them are physical change. But sharpening pencil is irreversible change, means cannot be undone. While freezing water, after changing water to ice, you can get it back liquid water. So this change is a reversible change and can be undone. So the difference between sharpening a pencil and freezing water is that sharpening a pencil is an irreversible change while making ice cubes is a reversible one. First question, explain how does a chemical change affect the composition? Chemical change always produce new matter, so it will change the composition. So there is a change in composition of matter. Name 4 possible clues that a chemical change has taken place. What are the clues for a chemical change? Transfer of energy, change in color, production of gas, formation of precipitate. Those are indicators for a chemical change. Compare. In a chemical reaction, how does the mass of reactant compare to mass of product? Mass of reactant always equal mass of product. So both of them are equal. 35. What is the main difference between physical change and chemical change? The main difference is the physical change. In physical change, no change in composition of matter, while in a chemical change there should be a change in composition of matter. This is the main difference. (36) Classify the following changes as physical or chemical. Water boils. Of course, boiling water is just a change in state, no change in composition, so it's a physical change. Milk turns sour. You are making yogurt and you change milk to yogurt. This is a chemical change, change in composition and taste and color. 3. Salt dissolves in water. Salt dissolves in water should be only physical because no change in composition, you can get both of them back very easily. a metal rust. Rusting a metal is a chemical change because there is a change in composition. Question 37. According to law of conservation of mass, when is the mass conserved? When is mass conserved? Mass is conserved in both physical change and chemical change. Question 38. Calculate hydrogen and oxygen react chemically to form water. So hydrogen reacts with oxygen to form water. Then how much water would form if 4.8 grams of hydrogen react with 38.4 grams oxygen? How much water will be produced? You just add them. It will be 43.2 grams. This is the mass of water that would be formed. When ammonium nitrate explodes, the products are nitrogen and oxygen and water. When 40 grams of ammonium nitrate explode, 14 grams of nitrogen and 8 grams of oxygen are produced. How many grams of water form? Let's first write the equation. The equation is ammonium nitrate explodes to give nitrogen and oxygen and water. Not important to write in formula, you can write just the words. He said that 40 grams of ammonium nitrate, so I have 40 grams here of ammonium nitrate explode and give 14 grams of nitrogen and 8 grams of oxygen. Okay, and how many grams of water form? So here I will write X gram water. To get the amount of water or the mass of water, we need to subtract 14 minus 14 plus 8 equal 18. So mass of water is 18. Here we are applying the formula if mass of product equal mass of reactants. Next question. Classify the following properties of the element silicon as chemical and physical properties. Blue and gray color. Whenever you have color or density or melting or boiling point, they are physical property. Brittle, it's also physical. Doesn't dissolve in water, it's physical. Melting point, all of those are physical properties. Well, the last one, react vigorously with fluorine. React with fluorine, it's a chemical reaction, so the last one only is a chemical property. Next, describe clues you might observe during the following event that could support the conclusion that a chemical change is occurring. An antacid tablet is dropped into water. Antacid, these are tablets, medicine, which is taken if you have an acidic stomach. Okay, so what clue you might observe, like what is evidence you might observe when you make this reaction to make sure or to say that a chemical change is happening? So adding antacid to water, it might produce bubbles. So bubbles or gas can be produced for the first one. Second one, a ring of scum formed around the bathtub. Around the bathtub you can see some green scum is formed. So here is a precipitate, something solid forms. Iron rust. Rusting iron lead to change in color. And then firecracker explodes. So explosion produces energy or there will be change in energy. Bubbles form when hydrogen peroxide poured onto an open wound. If you put hydrogen peroxide in an open wound, if you are injured, so you can see also bubbles or gas. Last one, a hamburger cooks. When you cook hamburger, so it will be energy change or color change or odor change. In photograph A, a coil of zinc metal is in a solution of sulfuric acid. Here they put zinc metal in sulfuric acid. In photograph B, a yellow solution of sodium chromate is being added to a colorless solution of silver nitrate. What clues in the photograph indicate that a chemical change is probably occurring? So for A, he put the coil of zinc in solution of sulfuric acid, so you may see bubbles. So in photograph A, the bubbles indicate that a chemical change is happening. And in photograph B, you can see there is a precipitate, something solid formed, and there is a color change. Next question. Classify each of the following as chemical or physical. Plastic drink bottles are burned in an incinerator to generate electricity. So when the plastic drink bottle, you burn it to produce electricity. If burning, there are clues for chemical change. So burn is a clue for a chemical change. So here I will write burning as the first clue for a chemical change. Remember that also bubbling or production of a gas, bubbles or gas is another clue. Third clue is formation of a precipitate. Fourth clue could be change in color or smell. So let's read here. Next question. Digesting cereal bar. When you digest something, of course, it's a chemical change because you change it into a new substance with new composition. Water in rain puddle evaporate. Evaporation is an indicator for a physical change. Slicing a tomato for a sandwich, like cutting tomato into pieces, it is just a physical change. So this one is physical and that one is also physical, but those are chemical. Plastic drink bottles are recycled to make fiber film for ski jackets. So recycled means you are going to change their shape only, but you will not change their composition. And this will be, of course, a physical change. Explain why production of a gas does not always mean that a chemical reaction has occurred. Because a gas may be released during a physical change, like bubbles that appear when water boils. Is water boiling physical or chemical? Yes, it's physical. So production of bubbles, if you boil some water and it produces bubbles, this doesn't mean that a chemical change is happening. It's just a sign for a normal physical change. The wax seems to disappear as a candle burns. When the candle burns, its wax disappears. How can the law of conservation of mass apply to this reaction? So the mass of the candle itself, the material, you feel that it disappeared. But what happened? It's going to change to something else. It's going to change into gases that disappear in air. So the wax appear to disappear because the product of the reaction, carbon dioxide and water vapor, are colorless gases. So the wax will change into carbon dioxide gas and water vapor. Both of them are colorless gas and they are going to disappear in air. But the total mass doesn't change. A change in color can also be a clue that a chemical change has occurred. Change in color. Describe at least one situation in which you might be likely to detect such a change in color, a change in odor in a kitchen. Okay, change in odor in a kitchen. If something burned in the kitchen, smell of food while cooking, smelling of something burning is one possible answer. Explain why this statement is false. Because there is no change in composition during a physical change, the appearance of the substance will not change. No, appearance of the substance will change even during a physical change. The first part is correct. There is no change in composition during a physical change. Yes, true. But the part which is wrong, the appearance will not change, because the appearance will change, for example, during a change in state. And this is a physical change. And paragraphs. The mass of the elements, iron and oxygen, in 4 samples of rust-colored substance was measured in grams. The amount of iron and oxygen in each sample is shown on the graph. So it is the mass of the elements, iron and oxygen, in 4 samples of rust. So we are comparing the mass of oxygen in 4 samples of rust. Okay? And here is the mass of the iron in the rust. Do you think all 4 samples are the same compound? These are the 4 samples, sample 1, 2, 3, and 4. Do you think all 4 samples are the same compound? Yes. All of them are rust, and rust had the same composition. And it's very clear here that the proportion is a straight line. If the graph is a straight line, so the proportion should be constant. So the ratio between iron and oxygen is constant whenever you go in the graph. Whenever you go in the graph between oxygen and iron, you will get a straight line, and this means that the proportion is constant. When you increase the mass of oxygen, mass of iron is also increasing with the same rate. Question 2. Another sample of similar material was found to contain 9.9 grams of iron and 3.4 grams of oxygen. Is this sample the same substance as the other 4 samples? Okay, let's see. If I have 4.4 grams of iron, first let's erase this. He's asking if you have another sample, a 5th sample of rust, has 9.9 grams of iron and 3.4 grams of oxygen. Is this sample the same or not as the 4 samples on the graph? So let's put them on the graph to see if the point, if they meet, if the 2 points meet on the line here, so I will say yes. If they are not falling on the line, so it's no. So 9.9 grams of iron, 9.9 like just below 10 here, okay, and the 3.4 oxygen. If this meet 3.4, does it meet 3.4? No. So this means that the point will not be on the line. If I make 9.9 with 3.4, most probably will fall below the line. If here, like 9.9 and 3.4, which is here, so they are going to intersect in this position. Okay, so they don't meet on the line. Okay, so I will say no. Okay, we'll say here no, because the point will not fall on the line. And this means that the mass of oxygen and iron, the ratio between them is different from those given on the graph. When powdered iron is left exposed to the air, it rusts. Explain why the mass of the rust is greater than the mass of powdered iron. Rusting means it's a chemical change, chemical reaction. And chemical reaction means that iron reacts with something in air. So iron rust is formed when it reacts with oxygen in the air to form an oxide. And of course, the mass of iron and oxygen is higher than the mass of the oxygen alone. Okay, so because the mass of rust equal the sum of mass of iron and the mass of oxygen. Each day you encounter some chemical changes that are helpful and some that are harmful to humans or the environment. Cite 3 examples of each type. For each example, list clues that identify the change as a chemical change. So we are going to give 3 examples of experiment that you encounter every day which prove that there is a chemical change happening. So you can say cooking food, changing color, or odor is an example. You can say burning a gasoline in car, burning gasoline in car. It produces also odor and energy change. You can mention anything. You can adding vinegar to soda. It's going to produce bubbles or gas. So give the example and evidence for the chemical change in that example. Here, in this question, are the physical change in the mystery? You have a story, you should read reversible or irreversible physical change and explain your answer. If you go to the story to read it, you will see that there are different signs for physical changes, like increasing pressure underground. And here you can see that the shaping of the valley by melt-refreeze cycles. So it's melting and refreezing. Both of them are physical changes. And also, the earth underneath is broken apart and moved, and this is also a physical change. Okay, so those changes are physical changes, and both of them are reversible. Okay, like water can change from steam to liquid, and the water can freeze and melt. Which of the following is a physical change? Conductivity. Yes, conductivity is a physical change. Right? Flammability, no. Boiling point is also a physical change. So 1 and 3 are both correct. Question 2. Which of the following is not a chemical property? Not a chemical property, so it's a physical property, like density, like mass, like density, melting point, boiling point, conductivity, and so on. Here, aluminium can be hammered into thin sheets. So hammering aluminium is not a chemical because it's only physical property. Question 3. Hydrogen combined with nitrogen to form ammonia. Which of the following correctly lists reactants and the product of this reaction? He said the hydrogen and the nitrogen combine to form ammonia. So hydrogen reacts with nitrogen to form ammonia. What are the reactants here? Both of those, nitrogen and hydrogen, are reactants, and what they produce is the product. Okay, so here the product is ammonia Reactant are both of nitrogen and hydrogen. Consider the following. W plus Z equal WZ. If 3.5 grams of W, 3.5, write them under W, completely combined with Z to form, so I don't know how much Z we have, to form 60 grams of WZ. So those produce 60 grams of WZ. What is the mass of Z needed? So Z equal 60 minus 35. It's not 3.5, it's 35. Minus 35 equal 25 grams. The figure below represents particulate diagrams of two different changes, X and Y. Which of the following correctly identify changes X and Y? X is a change from, it's a chemical change, right? Because I have here two elements, this one type of element and this is another type of element. They make a new compound, right? So the first one here is a chemical change. Y, it is just rearrangement of particles. Particles stay the same without any change in composition. So Y is a physical change. Student listed different properties of substance in his lab report. Classify each of the following as chemical or physical properties. Gas, so I am just describing it, right? Gas, I didn't say any chemical reaction, it is just physical. Flammable, so burning, it's a chemical. Colorless, physical. Highly reactive, chemical. Low boiling point, physical. So you are going to fill the table here. If 45 grams of substance X react with a substance Y to form 74 grams of substance XY. So if you are writing the equation, I will write that 45 grams of X react with Y, which we don't know, to give 74 grams of XY. And what is the value of Y, or what is the mass of Y? To get the mass of Y, very simple, you subtract 74 minus 45. Subtract 74 minus 45, you will get your answer. You have 2 marks for showing your work, 2 marks for the correct answer, report to 1 decimal place, and 1 mark for the correct unit. It's a very simple question and has 5 marks. Next question, list and define the law that govern above reaction. It's a law of conservation of mass. And then he said list and define. List, it is a law of conservation of mass. Define, mass is neither created nor destroyed in chemical reaction, or mass of reactant equal mass of product. And this is very simple. I prefer you to write this. Mass of reactants equal mass of products. Identify reactant and product. If X react with Y to form XY, so X and Y are both reactants and XY is the product. Now we'll go to the next section, learning objective 4. Learning objective 4 is about states of matter and its properties. You are going to read here the states of matter, solid, liquid, and gas, and the property of each state, properties of solid, properties of liquids, and those of gas. Let's go to the questions. No questions are given here, but it's very important to recognize those changes, okay, from gas to liquid condensation, liquid to gas evaporation, sublimation, deposition, freezing, melting, and the definition of each. Question 1, identify states of matter. Yes, there are 3, solid, liquids, and gas. Question 2. Compare and contrast. In what ways are liquids and gases alike, and in what ways they are different? In what ways liquids and solids different? So liquid and gases, both of them have indefinite shape. But how liquids and solids alike? Different. Solid and liquids, both of them have definite volume, right? But the difference between them is the shape. The shape of the solid is definite, while the shape of the liquid is indefinite. Here you have table for physical properties of some substance, and you have some questions on the right. Question 1. Identify which property can most easily distinguish chlorine from other gases. If you look at chlorine, what distinguishes it from other gases? Here is a chlorine. Okay? These are the gases we have. What distinguishes chlorine? The color, right? So the color of chlorine, green shell, because other gases are colorless. Question 2. A colorless liquid boils at 40. Which liquids here are colorless? This liquid is colorless, and this liquid is colorless. So your answer is one of two, the ethanol or water. Colorless liquid boils at 40. Is the substance water? Why and why not? If water should melt at 0 and boils at 100. So the substance which boils at 40, it's not water. Calculate which of the liquid substance had the highest melting point and the lowest boiling point. Which one had the highest melting point from the liquids? Here are the liquids, and these are the melting point. Which liquid has the highest melting point here? Water, because it has a melting point of 0. And which one has the lowest boiling? These are the boiling point. Which one has the lowest value? Yeah, it is that liquid which is bromine. Which of the properties would be the most helpful in identifying an unknown substance? So to identify an unknown substance, you need to look for the melting point or the boiling point of a substance, but looking at the color is not hard, it's not useful at all, because you can see that there are many gases have the same color. It's the same thing you can see with liquids or solids. What is the physical state of each of the following materials at room temperature? Gold. Everyone knows that gold is solid at room temperature. Gold is solid. Gasoline is liquid. It is the petrol of the car. Oxygen, gas. Neon is gas. Olive oil, all oils are liquids. Sulfur is solid. Mercury is liquid. Mercury is the liquid that we put in the thermometer. Finger polish remover. Fingernail polish remover, mostly acetone, is liquid at room temperature. Would you describe acetone in the gas state as vapor or a gas? This question is very important because it's confusing between many students. We say only vapor if the substance is liquid at room temperature. If it's normally liquid or solid, when it changes to gas, we call it vapor. Compare the arrangement of individual particles in solid, liquid, and gases. In solids, how the particles of matter are arranged. They are packed tightly together in orderly arrangement. So they are joined, tightly packed, and in a regular pattern that we call orderly arrangement. While in the liquids, the particles are in close contact but not in orderly arrangement. So particles may be close together but they are not in an order manner. Here are the particles in the liquid form. And in the gas, the particles are far apart. So in gas, particles are very far apart from each other. Then, question 46. Use the data table to answer question 63 to 66. Question 1. Which colorless substance is liquid at -30? First, let's look for which substances are colorless. Here and there and there. So your answer is either ethanol or neon or water. And then he say colorless substance liquid at -30. So its melting point is below 30. Melting point less than -30. Which of them? So water, wrong, the melting point is 0. Okay, so this is wrong. Neon minus 249, okay, which is very low, below 30, and also ethanol. Okay, so you're going to choose either ethanol or neon. 64. Which colorless substance is gas at 60? Gas at 60 means it boils before 60. Its boiling point should be below 60. Which one has boiling point below 60? I have bromine, but he say colorless, so we will not choose bromine. Okay, what else we have? We have neon, minus 246, very far below 60, and it's colorless gas. Next question, which substance is solid at 7 degrees Celsius? To be solid at 7, so the melting point should be more than 7. Okay, so at 7 it will be solid. Which one has a melting point above 7? Looking at the table, it's only sulfur. So the answer of this question is sulfur. 66. As the temperature rises, which solid will melt before mercury boils? Okay, so which solid will melt first before mercury boils? So I need the melting point. Looking at sulfur, the melting point is 115. First is asking about solids. So which one is solid in all of this table is only sulfur. It is the only solid in the table. Okay. So which solid will melt before mercury boils? The melting point of sulfur is 115. Boiling point of mercury is 357. This means that the sulfur melts before the mercury boils. That's why we have chosen sulfur here. Use the arrangement of particles in solid and gas to explain why solids are not as easy to compress as gas. He gives you a clue for your answer. Arrangement of particles in solids. So you will explain the arrangement of particles in solids. Particles in solids are packed tightly together. That's why we cannot compress a solid, while the particles of gas are spaced apart. Question 74. How are the items in each of the following pairs similar, and how they are different? Copper and silver. Both of them are elements, both of them are solids at room temperature, but they do have different colors. Copper is red while silver is silvery. They do have different melting and boiling point because they have different chemical composition. Distilled water and salt water. Both of them are liquids, both of them are colorless, but what is the difference? Melting and boiling point could be different, and water, distilled water, is a compound while salt water is a mixture. Table sugar and table salt. Both of them are white crystals. Both of them are soluble in water. But how they are different? Different in taste. Taste of sugar is different from the taste of table salt. Also, the melting and boiling point would be different because... Okay, next question. Discuss the statement, a gas requires container, but a solid is its own container. Gas requires a container because it expands to fill any space. It doesn't have a volume or shape without a container, while the solid doesn't need any container because it has definite shape and volume. Consider the following particulate diagram Q and P to answer questions 1 and 2. Which of the following correctly states that state of P and Q? P is solid and Q is a gas, right? So this is a correct answer. Next, which of the following is true about P and Q? P is solid, so is it compressible? No. So the first statement is wrong. Second one, particles in P has regular arrangement? Yes, because it's a solid. Particles in Q have low density and they can be compressed? Yes, because it's a gas. So both 2 and 3 are correct. Which of the following is true about gases? Indefinite shape? Yes. Indefinite volume? Yes. High compressibility? Yes. Gases are easily compressible. The physical change represented by the particulate diagram below is, what does this figure represent? It's a change of matter from solid to liquid. Change from solid to liquid is melting. So the answer here is A. Then here you have a table and you are asked to fill it by comparing properties of different states of matter in terms of shape, volume, and compressibility. First, solid has definite shape and definite volume. Liquids have definite volume but indefinite shape. Gas has indefinite shape and indefinite volume. Compressibility and can be compressed. Solids cannot be compressed. Liquids also difficult. Relative incompressible means difficult to get compressed. Liquid. Gases are highly compressible. And this table is very important to memorize for your exam. Consider the following particulate diagram to answer questions A and B. Which letter represents change that occurs by addition of heat? Addition of heat means you are going from particles that are tightly packed to particles that are separated and very far apart. So here I can say that melting happens by addition of heat and evaporation or boiling happens by addition of heat. So which of those represent melting and boiling? Or sublimation, because sublimation changes matter directly from solid to gas. Sublimation. So here, this is the solid. Look at the arrow direction. Solid to gas. This is sublimation. So it requires addition of heat. So I will choose letter V. Second letter here, solid to liquid, melting, and liquid to gas, evaporation or boiling. So P or V, all of them are correct. Removal of heat, cool down. When you cool down substance, you bring particles closer. If you have gas and you cool it down, the particles will get closer, forming liquid. And if you cool the liquid, it will be changed into solid. So those changes happen by removal of heat. Changing from liquid to solid is freezing. Changing of liquid to change of gas to liquid is condensation. So I will write here condensation. While changing liquid to solid is freezing. Both of them happen by removal of heat. So which change here in the diagram is from gas to liquid. This is gas and this is, so S represent condensation, while Q, liquid to solid, represent freezing, and also the deposition, which changes substance from gas to solids, U. So you can choose any of those letters. This is the letter that better fit each of the following statements. The state in which particles are highly compressible, it's only gas. The gas was represented by letter Z in the diagram. The state in which a particle can slide past each other. Sliding means matter in the liquid form. The liquid was represented by letter Y. The state in which a particle are closely packed, so we mean a solid. Look at the solid, it's letter X. Evaporation, change substance from liquid to gas, letter R. Sublimation, change substance from solid to gas, represented by letter V. Deposition, change substance from gas to solid directly, which was represented by letter U. Use the diagram below to identify the letter that best fits each of the following statements. Each letter may be used once, more than once, or not at all. So it's not necessary to use all the letters. First, state in which particles are incompressible and have definite shape. Incompressible have definite shape, so we mean solids. So they are particles of R. So the answer here is R. Second one, state in which particles have lowest density. Very low density means very light, and the particles are very far. So they should be in the gas form, T. Change of state from liquid to solid. Change in state, the answer should be something on the arrow. Change state. Change state from liquid to solid. Where is the liquid? Here. Or there, yes, S is liquid and solid is R. So what is? So the answer is Z. That represents condensation. Condensation change from gas to liquid. Yeah, look at the head of the arrow. Gas to liquid. So the answer is W. Change in state that require energy, and it should be added to separate the particles and keep them far apart from each other. So you are going to choose, here I can choose U or V or Y, any of them or all of them. Change of state that release energy. Release energy because you are cooling them down to the particles come closer. So which state, change of state here, show the particles come closer. I have W. In W the particles, okay, come closer, change from gas to liquid and from liquid to solid. So it's a W or Z or X. Okay, X represent sublimation or deposition. Yes, it's a deposition, change substance from gas to solid, and this happens when particles lose energy. So release energy means lose energy and come closer. Require energy means they will take energy and the particles will go farther apart.